So there's the vugginess aspect, the layering cyclic quality, and then finally you'll see one set of sine waves then which are paralleling the bands, and then those are showing dips then which are approximately pointing up towards the northwest, maybe north of northwest, and pretty low. See, we've got true dip 0 to 90. I can't even see this angle, but low dips. Now conversely though, these are high dips, 90 degrees, vertical dips. Look at the other sine waves, and that's these characteristics here, the ones that are almost going, well, they are going virtually orthogonal. That is picking up some of these features here, which are the fractures. On the one hand, you look at the dips that are either going about just a little less than 90 degrees to the north, or a little less than 90 degrees going to the south. You say, well, isn't that contradictory? You think, not really, because if I have something that's dipping this way, 95, and then I flip it just a few degrees, then whoa, I'm going completely opposite direction. And also you'll find the same thing that if you have very low dips, which of course is characteristic of Kansas, that you can say, well, we've got a dip of 2 degrees to the east. If I just pull it back, we're 2 degrees to the west. So you'll see a lot of variation then at either the bottom end or the top end there. So what's going on in the image log then? A lot of stuff that using its dip meter ancestry to pick out dips and strikes and features, at the same time actually allowing us to then see vugginess directly within that. Again, what you could think about these is that, say for example I say, oh, that's so cool they ran that, I can see where the vugs are. And furthermore, you can do optical processing of this thing to get the vugs out. I can go back to the conventional logs that they ran in that borehole and see if I can get something that's sensitive to vugs. I could calibrate it based on this and say after the races on the surrounding boreholes, just on those logs too. So always think about where you get an exotic, enhanced log, say, well, if somebody else ran it, that's great because they paid for it, but how can we use the information to feed into more conventional log suites? Just the same way as you had core information, great for the hole you've got the core from, but you're hoping you can use the information to the remaining wells. Okay, here's another image log. Now we're down in Barber County, and this is now we're into kind of gas shale business. This particular well was run in the hopes of getting gas shales then out of the Chattanooga shale right here. That is what we would call Chattanooga, at least I would. But since we're very close to the Oklahoma border, that would become the Woodford going down into Oklahoma. And above it is the Kinderhook shale. And kind of rather different in terms of images. Now first off, just for the heck of it, there's the Viola limestone, which we looked at in the previous section, and here you can see the imaging there, and those are, no question, those are drilling-induced fractures ripping through that system. Then we go into the shale. Monstrous gamma ray, it's gone off scale, and again, so 0 to 150, 150 to 300, that's going way over 300. So a lot of this then is associated with the organic matter then within that shale. Furthermore, on the imaging, you can see that looking at those shales, the more normal shale above the Kinderhook and the Chad, you can see this structure that is showing up here. Part of that will be changes in organic content. Because recall, if you've got higher organic content, that'll be higher resistivity. So some of that is the banding you see there. The other issue that people are looking for are natural fractures, if they occur. So it's been a little disappointing, as I understand it, that the imaging looking at shales like this in Kansas, and also Oklahoma more particularly, they haven't been able to pick up that much in the way of natural fractures then directly off the FMI. Other things to look for, though, is whether some of these issues here relate to whether those layers are more siliceous than others. So the idea is the more siliceous the layer is, the more brittle it's likely to be, the more susceptible it would be to, say, a frac job or some of that kind. So a lot of information they're trying to get out of this sequence. But anyhow, we go to the top then of the Chattanooga, and we see we're into more conventional shale, the Kinderhook shale there, which doesn't so much in the way of structure. This is one of my favorites. This is gorgeous. This is the Hushpupney Shale, which I understand is a gas producer in eastern Kansas. Look at the scale here. these are 2-foot bars, so we are looking then directly at that shale. Now, the way to think about it is this kind of bright candle color there, high resistivity. So you can actually see bands within it. The brighter it burns, the more organic matter it has, because it's causing high resistivity. Then we get above into this part. This is the gray phase part, where now we can actually see laminations then within the shell. And you can even see what kind of look like rootless structures, and there's quite possibly some pyrite within that sequence there. So yet again then, white is simply the gaps between those pads. Now this is Barber County, and we can compare this with this. We're up here in northeast Kansas, we're up in Leavenworth, and once again here is the Hushputney, but it's a different one. This is an actual core, and this is an X-radiograph done of the core, and you can see that same kind of fundamental structure. Here's our black shell phase down here, and then there's the upper phase there. So to me it's stunning in that that gives you yet another opportunity to say, what am I looking here? And finally we get it to say, wow, I'm actually seeing then the structure within that black shale. I say there's the possibilities then, is really picking up then where your organics are and so on. So very exciting log, especially if somebody else pays for it. Yeah. Okay, unfortunately, like I say, there's not that many image logs out that I'm aware of. Now I say not that I'm aware of because it is indeed a requirement for all logs to be filed with the Kansas Corporation Commission, ultimately get our hands on it, but sometimes people forget to put the FMI, sometimes it doesn't show up. And since people have spent a ton of money on it, I think, well, maybe their fingers got a little sticky because they say, well, geez, it's just simply going to sit up there and gather dust in some tomb, so why don't we just simply hold on to it? But the same point, these images that I showed there, they want from a copy. I got those as part of electronic file supplied to me. So once again, we moved into the digital age. But rather than saying, well, I've got the color log, how are we going to scan this, and does anybody know if Kinko's can do this? You'll get the image log directly for processing. And that's fairly common practice, because if you run the image logs, it kind of pays you to have somebody work on those, an expertise to tell you which are the natural fractures, which are drilling induced and so on, and they will definitely work on those image logs with workstations. Okay, here's another exotic log we don't see too many of, and that is nuclear magnetic resonance logging, NMR. That was the original mnemonic. This has been around a long time. Schlumberger used to run these back in the 80s, I think, maybe even the 70s. Expensive process, they need to dope the mud and do all sorts of things. And then an outfit called Newmar came along, and they saw if they could actually do nuclear magnetic resonance logging then in the subsurface. The fundamental principle involved is it's MRI logging. Just the same way as you go to hospital and you undergo a very claustrophobic experience, then having giant magnets aimed at your body, it's the same idea, except those giant magnets have got to find some way to cram them down an 8-inch borehole, which is what Newmar did. Physics is a little complex as far as I'm concerned, but in fact I once heard somebody explain it to me, and they said, you know the fundamental problem? There's a typo. It's right here, it should be UN, it should be unclear magnetic resonance logging, because poor Charlies like me struggle with what's actually going on. One thing is they tend to be a little shy about this nuclear stuff because people go hysterical when they hear nuclear, as everybody runs for the exits and what have you. But it's a sad, sad thing because it's got nothing to do with radioactive. It's the property then of the nucleus of the hydrogen atom that it has magnetic moment. That's what the nuclear is about. So more commonly these days they might call it MRI, magnetic resonance imaging, or CMR if it was a Schlumberger product. This is another instance too where you can make the measurements downhole, or you can make measurements on core, and then that way you can really try and lock on what exactly am I looking at downhole.